Hey, what's going on, everybody? Today we have a very good problem for you guys called the length of the last word, right? So length of the last word, so very good problem. So let's read the problem statement, right? So it says given a string S consisting of words and spaces, return the length of the last word in the string, right? So a word is a maximal substring consisting of non-space characters only. Okay, so pretty good definition. So what they've told us, right, is that we're given the string, all right, and our job is to return the length of the last word of the string, right? It's kind of the job that essentially we don't have, right? So for this one, it's pretty straightforward. So the last word is world, hello world, right? So it's of length 5. Okay, so that's why we have this. And then we have the example 2, which is a little bit more involved, right? We have a bunch of spaces, right? Leading and trailing spaces. But still though, right, the last word, right, is considered a word because they've told us what a word means, right? It's maximal substring consisting of non-space characters only. So this counts as a word, right? So it's his moon, it's of 4, so we return the word 4. Even though there are spaces there, they don't matter, right? Because they're not words, right? These are words, so that's what we have. And that's a word, right? Fly me to the moon, right? Is a word. So moon is the last one, so return 4. So this one is the same thing. We have Luffy is still Joy Boy, right? So the last word is Joy Boy, which is of length 6. So it's kind of what it is, the whole process, right? Is to return the length of the last word. Okay. So how can we go ahead and solve this problem, right? So we normally like to start off with the most intuitive approach on this channel, right? The approach that just makes sense to us, right? So what I'm thinking here. Okay, so what do we need to do? We have a big old string, right? It's a string. So we need to find a way to isolate the last word of the string, right? Okay, so since we have a string, right, what we could do, we could do splitting, right, based on spaces. All right, but before that, what we're going to do, right, is split, right? So when we split it, we will be able to get an array of, so each word will be indexed in an array, right? Okay. So before we even do the splitting, what we need to do is to remove the leading and trailing spaces, right? It's going to be very important to do, right? So once we do that, we could do the splitting, right? Then we get all the different words in some sort of an array, right? And then we just get access to the last element, right? The last word, because that would be the last element in the array because of the splitting, right? And by doing that, we get the result that we're looking for. We could just easily do last word, that length gives us 4, and then we return it, right? So this approach wouldn't be too bad, right? Actually, I'm going to show you guys that on the whiteboard. So yeah, like I was saying, right, it would be kind of, a good way to start, a good way to start with, do it right. So initially we clean up the spaces, leading and trailing spaces, right? Then we get the actual word, the moon, okay? And then we split it and based on the delimiter of like a space, right? Then we get the different words in different index, right? And then we just do the last word, right? The last word of the, because we get 2, so for this example, right, the moon, and we end up with 2 indexes, right? So index 0, index 1, right? So we just access the last element, and then we do that length on the string itself, right? And then we're able to return the length of 4, okay? So this wouldn't be too bad, right? But this simplicity, right? These abstractions of the function that we have here, right? They hide a lot of, bad things, right? Like for example, the memory footprint for those things are very, very high, right? Especially there are, so you do that trim, okay? So the strings are immutable. So they usually have to create a whole brand new string, right? And that include those spaces essentially, okay? So that's memory there. Then we can do the splitting aspect of things where we have to create, right? Say we have 10K words, right? And I only care about the last word, right? But because I'm calling those functions, right, the splitting has to allocate memory, right? An array of strings, right? For all of those 10,000 words that may be present in the string, right? And it creates memory for that. So the memory footprint also goes through the roof, right? So not only the time, right? We're doing a lot of crazy work because of the trimming, right? And also we're doing it for the splitting as well, right? So we have to be a little bit more clever, a little bit more efficient with the approach here, because we have to start thinking about it, right? So think about it, right? If you have a big page of words, and we're tasked to simply just find the length of the last word of the last word on that page, right? We wouldn't start off at the beginning of the page, right? You know, in the top left, right? We would look directly in the bottom right, because that's what I care about. I care about the last word on that page. So how about just work my way backwards that way, right? You know, and trying to find the word there, because that's what I want. I want the last word, not the first word, but the last word on that page. So it's similar to the same thinking, that we should utilize that thing to get the length of the last word. So how it would work essentially is that we're going to loop backwards. We'll loop backwards, right? We would, as soon as we encounter, so we need to handle that case where we have those trailing spaces. So these things, we would skip them. And as soon as we encounter a none white space or empty space, right, then we stop there, right? So, and then since now we've encountered the first word in the string, right? So we're going to call s-trim to trim it for us, right? To create a whole new string for us, allocate more memory, things like that. We do it ourselves. We skip the first, we skip all the trailing spaces, all right? And then after that, we stay there, and then we keep looking backwards until we hit a white space, okay? All right, we do that because we want to get the length of that particular word, right? So as soon as I encounter that word, I loop backwards. I do 1, 2, 3, 4, and I encounter a space right there. Then we know that we've looped all the way through our word, right? And that's where we stop there, and then we return the length, just like that, guys, right? So yeah, this is the hidden cost of the split function that I was telling you guys about earlier, where we have those, allocates new memory and things like that, right? We copied 10,000 character books. The same example that I was trying to tell you guys earlier, which is the wasted time cycles and the different memory footprint that we have to encounter with this. So this is the way that will explain the algorithm, right? We would start off with the looping backwards, where we look from 11 from this. So this is our string here, and then we loop backwards. As soon as we encounter a none empty space, we stop there, and then we do a second phase. And that phase, this is where we get the length of that that word. So we loop from 9, 8, 7, 6, and we encounter a space, we stop there. She's our indication that we need to stop, and then we return the length like that. We also have a variable called length that we also initialize. Okay, so hopefully it kind of makes sense to you guys. Let's go and implement the function. I think it'll make a lot more sense. The code is very intuitive. Right now the project I just showed you guys, right, is obviously a constant space, right? Because we're not utilizing any space. So let's cut this off, right? So we have our length initialized to 0, and we have our pointer, right? Because we're just using pointers to iterate through the string. Okay. So what I'm gonna do here is to make sure that we're not out of bounds, right? As we're going backwards, right? So the index should be initialized to s.length -1, because it's a 0 indexed, right? The arrays, okay, the strings as well, right? So we have that, and then what we do here, we check, right? This is our first phase. Our first phase says, right, if that character that I'm pointing at, right, is it a empty space? If it is, keep the current. Okay, she's our simulation of removing the trailing white spaces. Okay, so we've handled that case. So now this condition will stop as soon as we encounter a none white space, right? Okay, so now after we do that, we just loop again backwards. Okay, and then our condition will be a little bit different now. Okay, so now if it's not equal to a page space because I've stopped at a word, right? So I've gotten to there, move, right? So I skip, and then I get to this one as phase one, encounters the first non-empty space. Then we stop there, then we loop through the rest of those this, right? Backwards. So I'm gonna every iteration increment the length verbal, and then I'm also decrementing the point because I'm going to the left, right? I'm going from right to left. This is how you iterate through that, right? And after that, we just return the length. Okay. And just like that, we've been able to solve it, right? We have the first phase to skip the trailing white spaces, and then from there, right, we keep looping until we encounter space. And then as soon as we encounter space again, we know that that's the length of that word because we've iterated through all the characters of that word, essentially. Okay. So let's press run code. This looks like we passed a small test case. I press submit. Looks like we did, guys, right? And we've solved it in the best time complexity possible. So if you guys really like the problem, in the comment section, right? If you guys are new here, make sure to subscribe because we'll be doing a lot of other videos just like this one, right? So I want to thank you guys for watching, and I'll see you guys in the next video.